So welcome to the final exam review. I also kind of want to uh, start off and kind of warm up on some of the latest homework assignments. Um, there are problems out there that you should really be able to know how to handle. You should be able to use technology. You should be comfortable with the technology that you've been using. There are mainly two main technologies out there that really are good. It's the graphing calculator or StatCrunch. Either one of those is really good. It's really a matter of preference. Um, so what we'll do is just kind of first just kind of start off by looking at some homework problems, and then we will discuss the final exam as well. The focus of the final exam is mostly going to be more on the second half of the course. So chapter 6, 7, 8, 9, those chapters, those are going to be really, really good uh, problems that you should be working on. You should be really good at answering. So let's start off with 6.2. Let's look at a couple problems from 6.2. Keep in mind, all the homeworks are still open. You can do them at any time, and I expect most of you to take advantage of that. All right, so this is actually the binomial probability chapter, right? Yeah, chapter 6. Okay, good. So this is just really starting to warm us up. Let's try to jump in and see where some of the problems really jump in at. I'm going to go with, let's see here. Okay, here we go. Let's start here. It says determine if the following probability experiment represents a binomial experiment. If not, explain why. If the probability experiment is binomial, state the number of trials in the probability of success in P. So we're not really doing it yet. Soccer goalie who stops 50% of his shots is asked to make saves until he gives up a goal. The number of saves attempted is recorded. Well, it doesn't really say the fixed number of trials, and so for that reason, I will say no, that it isn't. I think one thing that's interesting is that they don't. It seems to me that they're not telling you whether or not you're right or not. So I think I'm reviewing the homework, but I'd rather not review it, but actually do it to improve my grade. So let's jump back in there. And this time what I'll do is click on 6.2 and not to review it. We want to do it. Let's see if that makes a difference. So we want to improve our score. And let's jump in. The fixed number of times, let's try trials. Nice. Yeah, we call it a success or failure. And here, I think we went with no because of the fixed trials. Well, okay, let's read this closer. Okay, so they are recording the number of free throws attempted. Let's see. I actually meant to choose B. Yeah, I misclicked. Now each shot will be independent of each other. But they have to have a specified number of trials. You can't just say, hey, go until you miss. You may not miss, right? So in order to carry out that experiment, we need certain things in place. So here are the things that we need in place to carry out a probability, a binomial probability. We need the number of trials, the probability of success, and then the X amount, right? These are the probability of successes, right? What is the probability of getting 38 successes out of 40, but your probability is 98? So it probably wouldn't be that difficult. The probability should be pretty high for this to happen. Let's calculate this. Now, there's 3 ways to calculate this: by hand, by calculator, or by StatCrunch. Okay, let's try calculator first, and I will tell you where to go for that. So the first thing we're going to do is go into second distribute, and we need to go over to binomial PDF. If you go all the way down to A, if you have this model calculator, you'll see binomial PDF. Hit enter. It prompts me for the commands to what to put in because I have on StatWizard. So if you don't have StatWizard, it will just tell you what you need to know what to put in. The first number to put in is the number of trials, that's 40. The second thing is the probability, so that is going to be a number less than 1, greater than 0. And then the exact number of successes. Alright, so it's not less than 38, it's not more than 38. We want to know exactly 38 out of 40. We want to know what is that probability of that happening. We don't even know the context. They just gave us the bare bones problem. Usually they give us a little bit of context and we have to pull this information out. But in this case, that's not what I'm seeing at all. Hit enter. We're getting 0.1447. They like you to round to usually 4 places. So I'm going to put in 0.1448. And we got it. Okay. That was using our calculator. Now, if we were actually to go back and do a similar question, this is very similar. It's 4038, but the probability is 96 this time. Let's use StatCrunch. Alright, so let's see if I have StatCrunch available. It's here. Hopefully it logs in okay. Doesn't give me any problems. Okay, that looks good. I'm going to go to Stat, Calculators, Binomial. My N was 40. My probability was 0.96. And I'm going with exactly 36 this time. What you're trying to find, you leave blank. Hey, it's more than 5%. It's probably likely to happen. 0.0538. Let's see if that is good. Let's make sure I've entered everything in correctly as well. Let's go back to StatCrunch. I did not get that one right. Our problem says 40, 38, and 0.96. Round to 4 places. I don't see what the problem is there. Let's double check that. Now it is it's saying between, its standard has been selected. 40, 36, 0.538. How could they not like that? Did I put in 36? I believe it's 38, isn't it? 0.2646. 2646. That's even better. Yeah, I thought for a second 5% was kind of low for that. It just makes sense. The probability is so high. Um, so, yeah, you probably could get 38 out of the 40. And that's like, for example, if someone is a 96% free throw shooter and they shoot free throws, or they shoot 40 free throws, what's the chances of them hitting 38 of them? They probably have a 0.2646 chance of getting all 38 out of 40. Alright, so this time they want us to calculate the probability of binomial experiment, but this time compute the probability of x successes in independent trials, and this is for x is less than 3, so less than or equal to 3. So what is the probability of getting 3, 2, 1, or 0? It's like 4 problems in one. We're not going to do exactly 1 plus exactly 0 plus exactly 2 plus exactly 3. We're not going to do that. We could do that, and it probably would work. Like, for example, let me demonstrate this for a second. It's possible to do the probability of x is less than 3. I don't know why it's writing so. I could let's use a better color, maybe like a dark blue or something like that. It would be this would be the answer, but there is a faster way to do this, and I will demonstrate on the calculator. So if we, let's clear all that. If we go back to our distribution, second vars, go all the way down. Instead of binomial PDF, which gives you the exact amount, we're going to do binomial CDF, which is the cumulative density function, since we are going to go from 3 all the way down to 0. We're going to choose that. The number of trials is 9. The probability is 0.9. And then our x value is 3. And now we're just going to hit enter. It pastes it onto the home screen. Hit it. I got a very, very small number. This is 0.00006. That's rounded off to 0. I'm going to choose 0 for that. They did not like that. Let's see. Alright. Since we're including 3, I'm thinking maybe we should add 4 to that. Okay, let's see. Let's do a second entry, and this time do 4. Okay. Four places. That's 0, 0, 0, 8, 9. That's 0, 0, 0, 9. No? Alright, let's try StatCrunch. This thing is getting, we gotta get warmed up. So we had 9. Our probability was 0.9. and then we're going less than or equal to 3. 0.0001. Actually, that's going to be 0.0001 if we round it off. All right. And that actually looks like my very first answer. So we did have it right. It's just that I didn't round it off. If we come back up here. Now, if I changed my mode to round to 4 places, it would round to 4 places. No scientific notation. See, they keep using scientific notation for that. Let's see. If I type that in, it should expand that out. Times 10 to the negative 5 power. .0001. Barely made it. For some reason, my calculator is just stuck on scientific notation, and it's in normal mode. It's a little frustrating, but I'm not going to do anything about it. We don't want to waste any time on that. It's fine. We had the right idea there. Let's move on. Okay, so this is the same problem, different numbers. Same thing. You find that you create your binomial distribution. All of these should add up to one whole. You can do exact amount for exactly 0, exactly 1, exactly 2, exactly 3, so on and so forth. We have the Trauser 6 probability is 0.15. You're going to build the full distribution. Then you can answer any question you want after that. Alright, yeah. I think it's time to move to, let's take a peek at chapter 7. Let's go to 7.2. I think 7.2 has a little bit of 7.1 on there as well, so we're going to start this. I don't have to improve my score, it just jumped me right in that time. The area that lies between these two. Well, we could just pull up StatCrunch again. Actually, I already had it up. Let's pull up our normal calculator. And we're going between these two z values. I forgot what they were. Negative 1.65 and positive 1.65. .9011. All right, what about between negative 2.33 and z is 1? Well, this time we will use our graphing calculator. We'll go into second distribute normal CDF. My lower bound is negative 2.33. Upper bound is 0. And that's it. Everything else is good. Since it's the standard normal distribution, the mean is 0. Standard deviation is 1. Since these are z-scores, I'm getting 0.4901. Fantastical. We got it. What about between these two? Same concept. Let's keep going. Find the area under the curve to the left of negative 2 and to the right of 2. And keep in mind, these are double because of the symmetry of the standard normal distribution. Once you find one, you just multiply by 2 and you're done. And also -2 is already 2 deviations from the mean, since the mean is 0, right? That's 2.5%. So you can almost say about 5% almost. I wonder if they'll give that to me. Oh, I was close. I was close. Let's use the technology there. Let's go with just one, and we're going to go with to the left of -2, 0.0227, and then you're going to double that number. So just 0.458. 2257, what is that? 4494. Four. What? Oh, I should put it for. I meant 0.455. Yeah, I mean we were right there. It's really we normally just say 5%. It's 2.5 in each tail after 2 deviations. But to be more precise, yeah, it's not quite 2.5. Let's keep going. Find the z-square such that the area under the normal curve to the left is 0.8. So graphically, this is what we're doing. Again, we are talking about the standard normal distribution, so mean is 1, standard deviation, or mean is 0, standard deviation is 0. What is the z-score so that, so I'm going to put a question mark, so that the area to the left, or the proportion to the left, is exactly 0.84. And in order to answer that, we have to use inverse norm. So on our calculator, we can go second distribute inverse norm number 3, 0.84. And we're getting 0.9945. Oh, it's, hold on. We need a z-score to the left. What did I just put in? What in the world? Wait, hold on. This should be more than 1. This 50% is 0. What in the world? Why am I missing that? Let's see, hold on. That's 0.84. That's almost 1 whole. I mean, I could guess and probably get it right. It's almost, it's like 16%. That's like 1. It's like right at 1. Literally. Um, let's use StatCrunch. Alright, so we're going with, the area left is 0.84. 9945. Oh, it was 2 places. Crap. I was putting in 4 places. They got me on that. Yeah, okay. Okay, that's fine. Let's redeem ourselves. The approximate z-score that corresponds to a right tail of 0.32. So there's a bunch of ways to do this. Let's draw it out for a second so that we're clear on what we're doing. So I'm going to say that this portion is 0.32. The area to the right tail. We need this z-score. We know this is 0. It's definitely positive. Here, negative. The question is what is it? Our calculator works for the area to the left, but this time they want us to do the area to the right. So one way to do that is subtract this from 1. So if we subtract it from 1, we get this area is 0.68. Because 0.68 plus 0.32 make up the whole thing. So I could just do inverse norm of 0.68 and be done with it. Okay. I just have to remember to round to 2 places. So it'd be 0.47. Okay. So this chapter isn't all that bad. It's all that bad. We're getting warmed up. We're getting warmed up. Yeah. Which of the following corresponds to this? Well, this is less than 44, so that's B. What is it? Well, it's the deviation is 8. It's almost 16%. Probably a little bit more than 16%. Probably like 20% or so. We could use technology to do this, no problem. Our lower bound, if you're using your calculator, lower bound some negative number, upper bound 44. The mean is 49. Let's do it. Normal CDF. My lower bound, I'm going to use that. That's fine. That's a very negative number. Upper bound is 44. My mean is 49. And the deviation was 8, I believe. So now we got 0.2660. Not much else really going on. The 96th percentile, so that's inverse norm. What does the 96th percentile mean? Well, I'll show you what it means. The mean is, in this case, is 50. Standard deviation is 7. So this is 57. This is 43. And the 96th percentile is approximately here. We want to know what number is that, such that the area to the left is exactly 0.96. This is an inverse norm problem. You do inverse norm 0.96 comma 50 comma 7. And you get your answer. So about, I'd guess at about 1.4. Actually, I take that back. I was thinking standard. It would be I would say like add another 5 points to this number. So about 62. Let's see how close I am. I don't know if I'm right there. So I'm going to put in 0.96 there. Let's go. I do have to change my mean though. And we're going to the area to the left, 62.25. That's fine. Alright, feeling a little warmed up. I'm getting there. Let's move on to 8. Let's take a look at chapter 8 real quick. Let's jump into 8 too. Alright. So it looks like we are dealing with proportions, sample proportions. Sample proportions, okay. Yeah, we're going to say, yeah, they do. We use the sample, no, not the sample proportions, the sampling distribution proportion does. They almost got me on that one. Yeah, so yeah, this is the sampling, the mean of the sampling proportion is equal to p. Yeah. Um, you could also say it's equal to mu, because mu. Well, hold on. The mean of the sampling proportions is equal to. I'm gonna change it to mu. I'm gonna call these guys equal. Technically, they are. Okay, so they probably wanted me to put p. Yeah, okay, that was more of a technical thing. In actuality, you could say that the mean of the sampling distribution is equal to the population mean. We know this. All right, we're just checking if the conditions are good here, right? Describe the sampling distribution of p hat. Assume the size of the population is 25,000. N is 300, P is 0.5. Well, let's check. Is it true that N is less than 5% of this? So if I do 5% of 25,000, is it greater than 300? Yes. Also, is n times p times 1 minus p bigger than 10? Well, p is 0.5. 1 minus p is 0.5. That's 0.25. That's a fourth. A fourth of 300 is not less than 10. A fourth of 300 is 75. So this is true as well. And so I'm going to go with it's approximately normal. And since we're here, let's double check our text, one of our textbooks here. We're talking about the sampling distribution of sample means, which is a little confusing topic for many, I'll admit. It's magical though. We know that this okay, we're not gonna mess this up. We're gonna put P, determine the mean of the sampling mean. Well, we're gonna say that it's P, which is 0.5. Okay, determine this one. Well, this one you actually need a formula for. Now, technology will do it as well. That's the formula. Standard deviation of the distribution is the square root of P minus 1 minus P all over the n. Now, P minus 0.5, that's 0.25. 0.5 times 0.5 is 0.25. And then divide that by 100, or by 300 rather. That's not too hard to calculate. We could say, hey, the square root of 0.25 divided by 300. And they wanted us to round to 3 places. So 0.9. Didn't take it at all. Well, we calculated that. Yeah, so we're just doing a bunch of homework stuff right now. We haven't really jumped into anything big time yet. Let's look at question from chapter 9. And let's go to 9.2. Or determine the t-value in each of the cases. So they want us to find the t-value such that the area to the left of the tell, the area in the right tell is 0.25 with a 26-degree freedom. Well, that's the same as the area to the left of 0.75. So if you don't have that on your calculator, you could do that. If I go to second distribute, I actually have the t distribution, the inverse t, number 4. But I'm going to put in the area to the left is 75. Same degree of freedom is 26. Let's see if it works. They wanted 3 places this time. That's 0.684. They're very picky with the places. What about the area to the same problem, different numbers. They want the right 10%, so we're going to put in the left 90 because our calculator works for 90. If we did do the StatCrunch, we are going to have to use a different distribution. Okay, we cannot use the normal distribution. We have to use the student distribution, and that is here. They wanted the area of 10%. I'll put in 90. And our degrees of freedom was, what did they say the degree of freedom was? 23? Okay. .32 or 319. Yeah, 9.2 wasn't too bad. I mean, you know, I just demonstrated a bunch of problems. I probably started from the easier ones, but I mean, we could go to the end and work our way back down if there's more problems that someone wants to see. So here, use the summary to determine the point estimate of the population and the margin of error. So so since this is our data, the middle number will be the point estimate, which is given to be 21.87, and that seems reasonable. They don't even want us to round, so they want us to put that in there. I'm going to do that, 21.87. And then the margin of error, so I would subtract that from that. Okay. I could also add it. 824, let's see. Let's take the mean and subtract. Oh, we can subtract the difference of these two and divide by 2 as well. We're trying to find how much is it from the mean to one of the end points. So what I could do on my calculator is just do 21.87 minus the lowest value, 21.824. Okay? Let's look at chapter 10, and I think that's where a lot of people are right now. And also, before we even go there, let's take a peek at, and I'm going to answer some questions that came in. There were some questions that did come in about chapter 10, and I do want to address those questions as well, but let's go to our syllabus. And under our homework calendar, let's just make sure that we are doing the required sections. So chapter 10 has 3 sections, but chapter 11 has 2. And also chapter 7 has 2 sections. I know there you might have seen the 7.4, do not work on it. You might have seen 11.3, do not work on it. It has been deleted. But chapter 10 does have 3 sections. And so let's jump into chapter 10 real quick. And what we could do is let's just start at 10.1 to kind of warm us up. It says 18 questions I saw. Kind of a big assignment. Luckily, we do get to drop some assignments. So if you didn't do that well on them, no worries. You do get to drop some of them. So this question is dealing with the type of error you get. So if we do not reject the null, but so in other words, we don't accept the alternative hypothesis and the alternative hypothesis is true. This happens when our alpha is too low. Remember, we have to compare our p-value to our alpha. When the p is low, reject the HO. HO is the null hypothesis, and p-value is the probability of that being correct. And depending on the severity of the study, that will determine the alpha, the level of significance which we compare to make our decision. It is that critical value. It's deep, guys. I mean, there's a lot going on with hypothesis testing, but now there are two different types of errors. There's a type 1 and a type 2. And if we go to chapter 10.1, they talk about the language of the language of hypothesis. So the type 2 error is when you don't reject the null and the alternative is true. That's what happened here. Type 1 error occurs if the null hypothesis is rejected when, in fact, the null hypothesis is true. A type 2 error occurs if the null hypothesis is not rejected when, in fact, the alternative hypothesis is true. Let's keep going. This is some good stuff. It's not too bad. It's pretty straightforward stuff. Just kind of get through this right now. It's all pretty basic. Let's do this one. According to a food website, the mean consumption of popcorn annually by Americans is 56 quarts. The marketing division of food website unleashes an aggressive campaign designed to get Americans to consume even more popcorn. Alright, determine the null and alternative hypothesis that would be used to test the effectiveness of this marketing campaign. So I'm going to say that the mean, which is mu, is equal to, actually for the alternative, for the null, the HO, should always have equality here. We're going to set that to 56. The alternative is that it's greater than 56. A sample of 879 Americans provided enough evidence to conclude that marketing campaign was effective. Provide a statement that should be put out by the marketing department. Well, we could say that there is sufficient evidence to conclude that the mean consumption of popcorn has risen. I like C. And okay, now they're getting into the, now you're going down the rabbit hole here. Let's try it. It says, suppose in fact the mean annual consumption of popcorn after marketing campaign is 56 quarts. Has a type 1 or type 2 error been made by the marketing department? If we test the hypotenuse at the alpha 0.1 level of significance, what is the probability of committing this error? Okay. So this goes back to what we were saying in the first place. Um, well, the alternative was true and they didn't reject it. So that is a type 2 error. We saw that before. And then the question becomes, um, the probability of making a type 2 error is what? Um, and before we even answer this, let's just go back to this part here. The level of significance is the probability of making a type 1 error. So the level of making a type 2 error would be is beta. Um, and let's make sure we have that language down real quick. Hold on. I'm assuming 1 minus the alpha is our beta for this one. Let's just make sure that we're good here. So I'm going to say one minus that, which is 0.99. I like that. Let's check again. So I'm assuming that the first part is right. Now the first question says suppose the fact that the okay. Oh, okay. Oh, I misinterpreted this. Okay. Oh, crap. Yeah, I misinterpreted. I read it wrong. So what they're saying is that the null is true, even though we found that the alternative is greater. So that is type 1, and also the error of that. Um, and the error of that is 0.1. Okay. Yeah, we didn't read it correctly there. It's a good problem. We would choose the smallest value. The smaller the value, the less chance of going wrong. Um, let's move on to section 10.2. We're super warmed up now. Now we're ready to get busy. Let's leave this. And Let's make sure that I have all the questions that I want to go over. There were some questions on chapter 10 that someone had questions on. I just want to make sure that I'm going to answer it. I'll go to it right now. Let me pull up the email. I think it's from 10.2. Let's see. It was a ask. There was a question from 10.3 as well. There was also a question from 9.2 that I might have skipped. Let's go back to 9.2 real fast. Question 7. The trade volume of a stock is the number of shares traded on the given day. Use the data from sample 1 to compute a point estimate for the population mean number of shares traded per day. Alright, so I'm going to open the data in StatCrunch, and then so I don't know what the mean is yet. Let's calculate the mean first. All that stuff. Man. The mean is 5.44. So that's what I'm going to put in, 5.44. And then it says, using the data from sample 1, construct a 95% interval for the population mean number of shares. Well, all right. Well, there's a couple ways we can do that. We can go back to StatCrunch. This isn't the one. Let's go to the other one. So I'm going to go to the 4.96 and 5.92. So we can be 95% confident that the population mean number of shares as a track is between 4.96 and 5.92. All right, they wanted us to use the t-distribution for that. Let's do that. So 4.94 and 4.94 and 5.94. This is like pulling teeth. If it's not this, then I don't know. I don't know. It better be this. I'm rounding it off, right? To two places too. Okay. Part C. Using the data from sample 2 constructed 95% confidence interval that the mean So okay, so they want us to do this again now. They want us to use the student distribution as well. So we'll go back to t-distribution 1 sample with the data, choose it, 95% compute, we're done. We just have to answer the questions now. We can be 95% confident that the population mean so wait, what was sample 2 all about anyway? $5.29. Okay, hold on. And also 6.36. Explain why the confidence intervals from are different. They're different because of the variation in the sampling, but I think there's an overlap. So the overlap between them is really key. The overlap is from 5.29 to 5.94. So to answer the question, it has to do with sampling and using the t-distribution. Now, there was a question on 10.3. And then we'll talk about the final exam a little bit more as well. And that question came from number 12. So calcium is essential to tree growth. In the 90s, the concentration of calcium in precipitation in this place uh, in New York was 0.11. A random sample of 8 dates in there gave us this data. A normal probability plot suggests the data could come from a population that's normal. A box plot does not show any outliers. Does the sample evidence suggest that calcium concentrates have changed since the 90s? Use the A 0.1 level of significance. And since they said change, we know we're going to set our null to equal, first of all, 0.11, but we're going to set our alternative to not equal to. So that will be a two-tailed test. Find the test statistic. Well, let's just do this problem using StatCrunch. The test statistics I'm getting is 1.25. Hopefully that works. And the p-value was 0.2522. Oh wait, did I not say it right? It's two. Oh, the three places, yeah. That's fine. So the p-value is actually larger than that alpha. So since the p-value is actually greater than alpha, we do not reject the null and conclude there is not sufficient evidence. So when the p is high, you do not reject the null. Okay. So that was a review of some of the chapters that questions that may have came up. The next part is what I'd like to do now is talk about our final exam next week. And let's be clear. The final exam is from June 13th to June 14th. That is from so you really do get 48 hours. And you only take it once. And that's how it is. So you have to take it within that window of time. Okay, so that's what you can expect on the test day. As far as some of the sections that you can expect, and actually the time and things of this sort, let's talk about that a little bit now. So I've set for 2 hours, and it appears to have 18 questions. The final is cumulative. The final is cumulative. Okay. It shows time remaining during the test. You're scrambling the questions. You can use the textbook StatCrunch and ask my instructor. If you do get locked out, message me so I can give you back access. Partial credit will be awarded as well. The number of sections I'm going to list now. 1.1, 1.2, 2.1, 3.4, 3.5, 5.4, 6.1, 7.2, 7.2. I really like 7.2. 3 questions from 7.2, 8.1 and 8.2. 9.1, 9.1, 10.1, 10.2, 10.3, and 1 question from 11. This is 18 total questions. These are the questions that must be studied if you are to do well on the test. These are the questions will come from these particular sections. Majority of the questions are coming from the second half material, 1 2/3, from 6.1 all the way down to 11.1. Chapter 5 is in there. It was, I don't think it was on the midterm, but 5.4, something from 5.4 pops up on that test. Okay. Yes, and keep in mind, I'm still around for questions if you have questions and whatnot. The practice is open. The practice closes Monday midnight, just like all the homeworks. And in fact, let me emphasize this. Practice exam all homeworks close Monday, June 12th at you are no longer able to work on the practice, and you are no longer able to work on the homeworks after Monday. That's non-negotiable. What I will say is you can print these puppies out. You can have a hard copy of them. And that's what I'm going to show you here. So if you go to Files, you go to Uploaded Media, you can go to the Practice Final Exam. This is it. This is the Practice Final Exam, and it has the solutions to all of them, all the problems. So it has been printed out for you. This is the knowledge that I'm giving you for watching this video. You are now equipped with the knowledge to prepare you for that final exam. As always, I'm going to end the video here. Thank you for watching. Let me know if you have any questions or comments.